In this video, we look at the steps for finding the inverse function. First, you replace f of x with y. Then you swap x and y in the function. We saw in previous videos that when you have a function and its inverse, you switch the domain and the range. So swapping the x and the y is switching the domain and the range. Solve for the new y, and then replace the new y with the notation f inverse x. So let's follow these steps using the example f of x equals square root of x plus 9 plus 1. So the first step is rewrite the function with y and x. So I have y equals the square root of x plus 9 quantity plus 1. And then I want to swap x and y. So I get x equals the square root of y plus 9 quantity plus 1. Now I want to go ahead and solve for the new y. So I'm on step 3. And so I want to solve for y. So to do that, I have a square root function. And so what I want to do is get all the terms other than the square root on the other side of the equation. So I'm going to go ahead and subtract 1 from both sides, and I'll get x minus 1 equals the square root of y plus 9. Now at this point, I want to get rid of that square root so that I can get y by itself. So I'm going to go ahead and square both sides of my equation. So I'll have x minus 1 squared on the left and the square root of y plus 9 quantity squared on the right. Now over here, x minus 1 squared, I have to multiply that out. Now you can FOIL it out, or you can use the box method to multiply. If you're doing the box method, you would do your x minus 1 on the top and x and then minus 1 on the side. So in the first box, you get x squared. Then x times negative 1 gives you minus 1x. X times negative 1 gives you another minus 1x. And negative 1 times negative 1 gives you plus 1. Combine your like terms. So we're going to have x squared minus 2x, because I combine the negative 1x plus negative 1x. So x squared minus 2x plus 1. And on the right-hand side, the square and the square root cancel each other out, and I end up with y plus 9. Now I just have to subtract 9 from both sides. And I get x squared minus 2x. 1 minus 9 is negative 8, so minus 8 equals y. This is my inverse function. So I'm going to go ahead and rewrite it up here using the inverse notation. So that's step 4 of finding the inverse function, is writing it with the proper notation. So I have f inverse x equals x squared minus 2x minus 8. All right, now the next part is to find the domain of f inverse in interval notation. So a quadratic can take any x value, but I will be restricted here because a quadratic, a parabola, is not 1-to-1. So I have to do a restriction so that I'm only looking at part of the parabola. And the restriction on the domain is going to come from the range of f. So if you recall from previous videos, the range of f is the domain of f inverse. All right, so that's a really important piece of information. Domain and range switch. So the range of f is the domain of f inverse. So what I want to think about is the range of f of x equals square root of x plus 9 plus 1. So the range of that is going to be all the possible y values. Now I know that the lowest value that a square root can be is 0. So the lowest y value of square root of x plus 9 would be a 0, and then add a 1. So the lowest y value of that function would be y equals 1. So let me graph it. And you can actually see. So I'm going to put in y equals square root of x plus 9 quantity plus 1. And you can see in the graph that the lowest y value is a positive 1, and the graph goes upward continuously forever. So the range of f of x is going to be 1 to infinity. So this would be is bracket, 1 is included, so it's going to be 1 to infinity. So the domain of f inverse x is x goes from 1 to infinity. So here I was talking about a range, so I was talking about a y value of 1 to infinity. Here I'm talking about a domain of the inverse, so I'm talking about the x values going from 1 to infinity. Let's graph the inverse and put in this restriction and see what it looks like. So for my second function, I'll put in y equals x squared minus 2x minus 8. And I want to put in that restriction. So the way we put in a domain restriction is we use a set bracket right here. And I want x to be greater than or equal to 1. So I'll put x. From my keyboard, I'll put the greater than, and then I'll put the equals symbol or the equals key from my keyboard. So greater than or equal to 1. Close off your set bracket. And we've got a nice visual here that shows that these two functions are symmetric over the line y equals x. And so I'm pretty sure that we got the correct inverse function and the correct domain, because my two functions are symmetric over y equals x. So that's all the problem was asking for. It was asking for the inverse function, and it was also asking for this domain. And you get the domain by figuring out the range of your original function. Let's look at one more example. Here, we want to find the inverse for g of x equals x squared minus 8 for the domain negative infinity to 0, and state the domain of g inverse in interval notation. So again, I have to have this domain restriction because a parabola is not 1-to-1. So if I look at the parabola x squared minus 8 with that domain restriction, so y equals x squared minus 8, and we have the domain restriction negative infinity to 0. So I'll put in the set bracket, x is less than or equal to, let me peek one more time, 0. Okay, so I'm only taking half the parabola, the left half of the parabola. All right. So I want to go ahead and follow the steps from the last slide. So I'm going to start by doing y equals x squared minus 8. I want to swap x and y. So I'll have x equals y squared minus 8. I want to solve for the new y. So I'll add 8 to both sides. I get x plus 8 equals y squared. And let me just rewrite this as y squared equals x plus 8. Now here's the tricky part. When I take the square root of both sides, if you recall from the first unit, I have to have plus or minus. So I'll have y equals plus or minus the square root of x plus 8. Now I have to figure out whether to use the positive or the negative here. And that's going to come from which half of the parabola was used for the original function g of x. In this case, we used the left half. We know that the domain of our original was negative infinity to 0. So that means that the range of the inverse has to be negative infinity to 0. So range of g inverse x has to be negative infinity to 0. So I'm using the fact that the domain of g becomes the range of g inverse, and the range of g becomes the domain of g inverse. So if I want my function, my g inverse function, to be negative numbers, negative infinity to 0, that tells me that I have to use the negative and only the negative. So I'm going to use the negative because the range has to be negative infinity to 0. So I only want to take on the negative values. So my inverse function is going to be g inverse x equals negative square root of x plus 8. And again, I decided to use the negative because I needed my range of the inverse function to match up with my domain of the original function. All right, now we go to the domain of G inverse. The domain of G inverse X is the range of G of X. So I know that G of X was X squared minus 8. And this is a quadratic, so I can figure out that the minimum X value here, I'm sorry, the minimum Y value here is going to be -8. And so the range of G of X is going to be -8 to infinity. And I wrote that wrong. I wrote -infinity, but I meant to write a -8. And so the domain of G inverse X is -8 to infinity. And actually, I could have figured that out by saying, okay, I have a square root function as my inverse, and so I need to set the radicand, the part underneath the square root, to be greater than or equal to 0. And that would have given me the same domain. So let me go ahead and graph these two functions and see if we've got the symmetry that we need. I've already graphed the first one, y equals x squared minus 8 for x less than or equal to 0. The inverse is y equals negative square root of x plus 8. And you can see from these two graphs that we have the symmetry over the line y equals x. And that's a really good visual way to check that you have the correct inverse and that you have the correct restrictions on domain. And you can also see that the domain of G of X, your inverse, goes from -8 onward to infinity.